So in this video, I'm going to be showing my FitsConverter that I've been working on lately and some astronomy images. A year ago, my dad took an image of M42 on a telescope at a star party, and then recently he took another one on a different telescope at a star party. Anyways, we're going to look at both of those using my new FitsConverter. So to start out, we're going to look at the old image. So to do this, you would. So what FitsConverter does is it takes a space image, a Fits image, and then it features a bunch of colorized modes. So for each colorized mode, it will generate an image from the float data. And additionally, for each colorized mode, it generates images of different stripes. So these are the colorized modes that it's going to generate. So we're going to run this program. This is a really large image, so it takes a moment. So it generated a bunch of images, and so what happens is with the striping is that it causes contours to be drawn across the data. The constant striping. So this is a color mode called binary, and this is M42 in binary 1. We can go up in stripe count. So what this means is that all the black in here is the lower half of the float space, and all the white in here is the upper half of the float space. That's why it's called binary. It's either high or low. This is 100% white or 100% black. And so we can increase the stripe num. So now there's a stripe number 2. So now this float space has been divided even more than it was earlier, which is only twice. Okay, and then keep going up. So I'm going to be examining these images some. So this is an area that I'm examining both images, or both M42 images. So there's a lot of images to go through here, so we're going to look at this. So this is binary 100 of M42 a year ago. Okay, so there's other color modes. So going up even further in number of contours or stripes, can move from binary to grayscale, which you've seen before. So this is a grayscale of M42. We're going to increase the stripe count. Last image of grayscale. Okay, we can increase the striping further by going to another color mode, and this is colored, and it's called RGB. And so the pixel, one of the things that happened recently in code is I found that there's since I work with bytes, there's different kinds of computers, and the byte order had been swapped in early revisions, such that a low value was reddish, but now a very high value is red and a very low value is blue in RGB. So this is RGB. Increase the stripes. So I'm going to try to get through a lot of images here. It's lagging. Okay, this is another color mode um, called short in RGB. It's smaller than normal in RGB by a byte. So red now is very low value, whereas before it was blue, which was the incorrect. So now it should be more detailed. Incorrect. So this program only can zoom 800%. I'm going to work on a program that can further zoom for these videos. So there's one more color format, which is in RGB rather than short. This should be more detailed than the previous one. Okay, so in a minute I'm going to talk about the code sum, and then we're going to move on to the new image of M42, and then some other images as well. Okay, so let's look at the FitsConverter code. So it starts in this function that you pass the file name to for fits. And it's got these methods: write colorized images, read fits images. So it reads fits images. So a fits image can have multiple images inside it, the fits file. So it's going to read all the images into fits file. This routine isn't necessarily super robust for any given a lot of fits files, but it seems to work pretty well. So anyways, this is a fits file reading routine, and then it calls, for each image, it calls write colorized images. So this is going to save the BMPs. So for each color mode, and for each stripe, it calls float space convert. So float space convert, it takes a bunch of floats. You have a bunch of float data from somewhere, and that's called the float space, and it's going to convert it into like a pixel that can be displayed on a monitor or in an image. So it has this function get view window, lets you limits the float space by excluding either min or maximum values. And so the default is to not do that. And so start percent would be 0, and end percent would be 1 for full image. So it gets view window, and then in view distance. And then it gets stripe distance. Stripe distance is view distance divided by stripe num. So the view distance is partitioned basically into a bunch of stripe distances. So then it switches on the color mode. For each pixel, you pass in a color function. This is the colorize function. There's like for each pixel in RGB, for each pixel RGB, grayscale, binary, sRGB, and these are defined up here. And so for nRGB, it takes the maximum value of 3 bytes, which would be RGB on an image. And this is the transform. It's just a linear sort of grayscale. The short nRGB only uses 2 bytes rather than 3. So the effect this nRGB has, this percent striping across these 3 bytes, is that as the value increases from 0 to 255, it has a color, and then when data moves into the middle byte, it's a different color, and that causes the idea is for every single value there's a different color, and because the colors alternate, you can see change. Anyways, so for each pixel, it calls this function convert to grayscale. Or for each float. For every float in the data, float space data, it calls convert to grayscale. Convert to grayscale is a modified grayscale function. The modification is that we sort of move all of the floats into the same space. And so because that happened, there's the appearance of contours. Anyways, so this returns a percent. And it gets passed to a colorize function. The colorize functions we've already been over. They all take a percent, and they return, in the case of nRGB and sNRGB, they return this sort of 2 byte or 3 byte value, grayscale value. And then for RGB, there's some kind of rainbow calculating routine, and for grayscale, it's very simple, and binary is even simpler. Okay, let's look at the next image. So these are old ones from different revision. So this is a different telescope. This is a pretty large image, apparently. Okay. And okay, this is M42 recently on a different telescope. Lagging. So this part is quite a bit different than the other one. These three stars are still there. These stars. Grayscale. And these are differentiated really easily. It's pretty cool. Okay, I'm going to do one more space image. This is the sun by some sort of telescope, space telescope, I think. Guys, there's one more group to do. Okie-doke. I'm going to make more videos of different space images later. Anyways, you can do this with FitsConverter.